Okay, so it looks like we're closing in around like 46 people. So thank you for everyone for joining us today. My name is Joshua Zhang. I'm a sophomore computer science major here at Texas A&M, and I'm also part of the logistics team for TAMU Datathon. And today I'll be your moderator for this lesson. Okay, our speaker for this lesson is Seth Hamilton. Seth is an electrical engineer and computer science double degree at Texas A&M, and he's also part of our TAMU Datathon logistics team. He has a lot of experience using data science and machine learning. He's used it to automate stock trading, work on school labs, and to compete in last year's Datathon. So he has a lot of knowledge to share with us, so we look forward to hearing what he has to say. Also, as a side note, I'd like to point out that this meeting will be recorded. So if you're in this meeting, you will be recorded. So if you don't want to be recorded, please leave, but otherwise you will be recorded. Okay, so with that, I'll hand it off to Seth and let's see what he has to share with us today.
Cool. All right, well, thanks, Joshua, and welcome everybody. This is our very first boot camp that we're doing as an organization. So we're really happy you guys are all here. We're super excited to teach you guys some stuff and hopefully get some feedback. Before we jump in, I want to go over just a couple things, namely mention the structure of this lesson. So we'll be kind of dividing this lesson up into two segments. One of them is going to focus on teaching the basics of the pandas data structure, or excuse me, Python package. And then the second half is going to focus on visualization. So we're going to have about like a 45 to 50-minute session, and then we'll have a Q&A, as well as hopefully getting some feedback from you guys. And then we'll have a second segment that's around the same amount of time for visualization, and then get some feedback and questions and stuff like that. So just so you guys are aware. If you don't want to do visualization, that's fine. Just, engage in the Q&A, fill out the form for the first segment, and then you can head out, or just stay for the whole entire time. Cool. Okay, so I'm going to hopefully make this as interactive as possible. So if you guys could follow along with me, let's see if I can share my screen. Okay, Joshua, you want to enable screen sharing for me?
Okay, yeah, give me a sec. Okay. Can you share now?
Yeah, let me see. Also, to answer your question, Hamza, I think that we'll be posting these recordings on the website. Okay, cool. You guys see my screen? Josh?
There we go. Now it's working.
Okay, cool, awesome. All right, so if everybody could quick jump over to a web browser, I'm going to show you guys a integrated development environment, or IDE, for data science type stuff that's called Google Colab. So if you all want to Google, or in my case for Google Colab, and then click this link here, colab.research.google.com/notebook. This will open up kind of this UI, at which point that you can create a new notebook. So I'm going to just create a new notebook, and it'll bring me to this page. So again, that was Colab. So you Google for Colab, and then this link, which brings you, and then there should be an option to create a new notebook. If you didn't see that dialog that popped up for me initially, you can always go to File, New Notebook. Okay, cool. Playground, since we're just going to be kind of doing just a bunch of stuff, we're going to learn a whole lot. And yeah, so this is Google Colab. So Google Colab is a kind of a wrapper around an IDE called Jupyter Lab. So if any of you are familiar with Jupyter Lab, this is exactly the same thing. It just looks a little different. But what's cool about Colab is it's running completely in the cloud. You have access to all of the packages. So when you don't have to go and like pip install anything, so you don't have to install this stuff. So it all comes kind of loaded, ready to go. And Google actually provides access to a kind of a low-powered GPU in the background. So each of these instances, when you're running code and stuff like that, you can actually run parallelizable machine learning and stuff like that. And that's not going to be important for our lesson, but that might be important for Josiah's lesson on machine learning. So I'm going to click the connect button over here. So it starts up the instance. Google goes ahead and like makes this actually able to run code. All right. So what we're going to cover in this lesson is how to find data. So we're going to look at some places to find a data set. We're going to look into how to load that data set. We're going to quickly go over that. And then we're going to dive into how to use the pandas package and the two big data structures that come with that, the data frame and the pandas series. And if you guys can understand those two data structures and how to manipulate them and play with them, you're in a really good position to do some cool stuff with data science. And this lesson isn't going to go as much into the math or the statistics. We're just going to look at the tools. Okay, so where to find data. So there's two sites that I want to show you guys. So you can do another Google search and search for Google data sets. And it's the first link that shows up for me. It's datasets.research.google.com. I'm actually going to take off my headphones because I'm having trouble hearing myself. Okay. Josh, can you hear me?
Yes, we can hear you. It's all good.
Cool. Let me just adjust my. All right, so here we are on Google Dataset Search. So if you're used to Google Scholar, this is kind of similar. So it's a great like place to search for a particular type of thing. So I'm searching for data sets. Texas, because I'm interested in seeing how the coronavirus has affected Texas and how it's progressed over time. So your first step might be to go to Google Dataset Search. You might search for coronavirus, and then you come over here to one of these websites, and hopefully do your own vetting. Not all of these websites, I think, are completely valid. You know, if you're doing real work, make sure that you know where you're getting your data set from. But in this case, this is the CDC, which I trust. So we come down here to Texas. We can come to like the Texas site, maybe click COVID-19. We're looking around for data. There's a link here for additional data sets. And then we can find maybe some links to data sets that might be useful to us. In this case, I'm going to right click fatalities over time by county, and I'm going to copy that link. And then jump back to Playground. Cool. So we just went through the process of going to Google Dataset Search. We searched for a data set. We kind of went through a couple websites to find a link to some data that we're interested in. And now we want to get that data set into our code here. And what I'm about to do, this is probably if you're completely new to Python and pandas and stuff like that. I'm going to kind of gloss over a bunch here. We're going to go into much more detail about how this stuff works, but just bear with me for a second.
Okay. Hey Seth, sorry to interrupt, but could you do the last step one more time? Some people are having trouble. You went a little fast. So just like going back to the link.
It's really low. Give me 1 second here. Sure. All right. I can do the last step one more time. So
thanks.
In fact, I will go ahead and send this link in chat. If I could, here. And sure, I'll go through that process one more time. So what I did was I went to Google Datasets. So I went to this Google Dataset site, dataset.research.google.com. And then I searched for coronavirus. Oops, that was misspelled. That's okay. And then I here and clicked on Texas, which brought me to the Texas site. Texas Health and Human Services. I clicked COVID-19 and I clicked the Texas COVID-19 data additional data sets. Cool. And then I got the link here. So I wanted the link to if I were to click this, and I can click this for now, notice that it downloaded an Excel file. So there's actually like an Excel file hiding behind this link. But instead of downloading it, what I did was I just copied the link, and I'm going to use that link to pull that Excel file into Colab. Does that answer your question?
I think that was good.
Awesome. All right. So first step we're going to write is import pandas as PD. So this goes and grabs the pandas package and gives it the alias PD. So whenever we refer to pandas, we just type PD. If you want to run a cell or block of code in Colab, you can press the play button to run it. Or if you're on Windows, you can press Shift-Enter to run it and then jump to the code block below. Or you can press Control-Enter to just run that block, and you don't create a new block. So those are 3 different ways to do that. That's the play button, Shift-Enter, and Control-Enter. Okay. So we want to use that link. So what we're going to say is, and I'll write out the code here, and you guys can follow along, and then I'll explain what happened or why this works. So I pasted the link that we found to the Excel file inside of Read Excel, and it went ahead and downloaded it and read it into this variable called df, which is, I'm saying, is short for data frame. And another quirk about Colab is that if you leave a variable as the last line of a code block, it'll print out what that variable holds. Or if you have a function that returns something, it'll print it out. So oftentimes what you'll see is, we're writing some stuff and then we just have the variable name at the very bottom line. And that's because we want to print out what's at the bottom. So taking a look at this, this isn't very pretty. There's a lot of, this header is kind of messed up. There's this disclaimer. There's all these like NANs, which we don't know what those are. This is all kind of ugly. And as you get better and you get better at like looking at these things, and it also might be helpful to like open up the Excel file, which actually, you know what? I'll do that right now. I'll open up the Excel file and show you guys. No, I do not want to create an Office account. Goodbye. Okay, well, never mind. We're not going to open up Excel right now. But basically, yeah, we've got, this is basically an Excel file being stored inside of a variable. And we want this line, and again, I'm glossing over a bunch of stuff. We're going to go in more detail later. But this line to be the header of our Excel file, right? So this header we don't like. We want to get rid of this line. We would like this line to be up at the top because it looks like all the data that we're interested in starts after that. And it also looks like there's a bunch of lines at the bottom that we don't like, that we want to remove. But let's get that header fixed. So there is an option that you can write in the read Excel function where you say header equals and then the line that you want the header to be. In this case, 012. I want it to be this line. So if I say header equals 2, on that, we can see that the header becomes the line that we wanted, which is this line. So that looks a lot nicer already. Are there any questions so far?
It doesn't look anybody has any questions, but if you guys ever have questions at any time, make sure to put it in the chat. I'll forward it to Seth or I'll answer it specifically within the chat.
Awesome, thanks Josh. So we have a data frame here that looks kind of nice, but it's still not, we're still not quite there. We know that we don't really want these lines here at the bottom, right? And we also might be asking like, what is NaN anyway? So NaN would basically be a null value or an empty cell in an Excel spreadsheet. NaN stands for not a number. So we're not really interested in these lines. And if we were to view the Excel file, you would see that those lines have like no information on them and we can safely get rid of them. So what I'm going to do is I'm going to write a fancy line. And if this doesn't make that much sense. We'll go over it later if we have time. So we're going to drop the lines off the bottom. Okay. So what this does, let me run this. It dropped the bottom 5. It looks like I need a couple more. In fact, maybe 1, 2, 3, 4 more. So let me make that 9. Yeah, so there you go. We've dropped those bottom rows, which we don't like. This is the bottom of the information that we're interested in. And we have the header that we like. Okay, so that whole exercise was go to googledatasets.com, search for a data set that you might be interested in. That's a great place to go find data sets. Pull it into pandas or pull it into a data frame object using the function read Excel. And then we set the header to a different line and dropped the bottom 9 rows. Again, that was super kind of quick and that did a bunch of stuff. We're going to start from the basics for the data frame data structure in a little bit. But I want to show you guys, before we do that, one other cool website to find this type of information. So if you Google for Kaggle or just type in kaggle.com, this is an amazing website to do data science competitions, find notebooks or code that other people have done for data science. Kaggle actually hosts their own notebooks, so something very similar to Colab. They actually have their own kind of Jupyter Lab version as well, but they also have their own data sets. So they host a bunch of data sets. So if you're interested in, I don't know, finding a data set, I think I searched for this the other day. You search for Spotify. Let's say you're interested in doing some analysis of how music trends have kind of changed over time. We can just take a look at the top one here. And what's great about Kaggle, and when you're searching their data sets, is they give you this really nice overview of what the data set contains and stuff like that. So you can even maximize these views. We can look at like the beats per minute, the genre. You can even see like the percentage for each of those genres that are represented in that column. So it's pretty cool. You can see that like for whatever data set this is, Ed Sheeran is like 8% or something, which is pretty cool. All right. So this is another place to get a data set, and you can download the data sets by pressing this button. All right. So that was how to find some data sets and load them. Just a very quick overview. If you want to create a new code block, what I did there was I pressed Shift-Enter, which ran the block that I was in and jumped down. However, if that doesn't work for you for whatever reason, or you prefer to do it this way, if you hover in like the middle area beneath the last code block or in between any 2 code blocks, I think, there's a plus code or plus text. So yeah, plus code or plus text. If you click this, it creates a new code block. All right. All right, so let's start talking about pandas. So I'm going to write some code here, and this is going to be the pattern for most of the lesson. Is I'm going to write some code, I'm going to explain it, and then we'll move on to the next block. Okay, so this is what's known as a pandas series. A series is basically like a single column in an Excel spreadsheet, if you think about it that way. So if you have like a table of information, a single column is called a pandas series. And in this case, what I have is a series containing the numbers 1, 3, 4, and 2. So I gave it a list of numbers, and I passed that into the series constructor, and it returned a pandas series with 1, 3, 4, 2. It's pretty self-explanatory, right? So another thing about Panda series is that they're not just like one-dimensional objects. They have these indices, right? So if I wanted to access a number inside of a series, I can use an index. So I can say s at 2, and that will give me 4, right? So pretty basic. If you're used to any sort of computer science, you're used to an array, you're very used to kind of indexing into like a particular section of the array. However, it's possible to also have custom indices. So if I said index equals A, B, C, D, what I'll get is A, B, C, D, where A matches to 1, B matches to 3, and so on and so forth. And this time, if I want to grab something, I would say S at A, right? And that would return 1. So basically, it's pretty simple, which you can index, and you can also have custom indices. All right, moving on. So give me 1 second here. Okay, I do see that we have some questions in chat.
So there was a quick question. What's the biggest difference between a data frame and a series? Because they both seem to do very similar things. Could you elaborate a little bit on what the differences are?
Sure, yeah. So a data frame is actually a collection of series. So you can think about a series as being a single column, whereas a data frame is a collection of series. So a data frame is like, and we'll get to this and you'll see what I mean in like a second. But if I were to jump into here, this data frame is called df, right? So if I say data frame at, and then I give it a column name. So let's say I'm interested in grabbing the population column. If I were to run that, that returns a data frame, excuse me, it returns a series. So whenever I grab a column, that's a series. If I grab a row, that's a series. So a data frame is basically built out of series, if that makes sense. So series is like this, the low level, and data frame is built off of series. Does that answer the question?
I think that answers the question.
Okay.
And then another question was, why not just use NumPy for all of this? What's the advantage of using pandas?
Okay, so you will see that when we jump into some of the visualization stuff. There's a bunch of reasons to use pandas over NumPy. I know NumPy is pretty powerful. They've got some really cool functions, but the pandas is really ambitious and it tries to do a whole bunch of stuff at the same time. If any of you guys are familiar with SQL, and we'll get into this in a little bit or later, you can actually do merges of tables together. So we can do merges, joins, and all these like fancy things that I don't think NumPy can do, because it really tries to treat data like it's a table. It's very similar to the way SQL thinks about information. So if you're used to SQL, you'll start seeing a lot of parallels come up in pandas. As for NumPy, I actually don't know the full extent of NumPy, so I can't speak to NumPy or what the exact difference is, but I know that pandas does make it really easy to do a bunch of stuff. Yeah, and pandas can handle a bunch of other different, NumPy I think is just meant to handle integers and floating point numbers and stuff like that, whereas pandas can handle strings and other different types of data, like categorical types of data and things like that, and we'll see some of that in this lesson. Okay, and I think that's it for questions, right?
Nope, that's it for now.
Cool. All right, so we took a look at a series. There's a bunch of functions that you can perform on a series, and we'll see an example of that called the sum function. So if I run s.sum, it'll add up all the numbers in the series. So pretty basic. It can be helpful if you have a series of numbers. That's just an example. If you want more functions, you can always look up a bunch of aggregation type functions for a pandas series. To show you guys everything in pandas would be insane. So we're really just going to give you kind of a broad overview of some of the foundational type of functions and things like that. Okay. So talked about a series. We talked about how to access a series. Let's talk about data types for a second. So we mentioned that something that sets apart pandas from NumPy, one of those things is probably data types. Also, I apologize if you pick up a thunderstorm in the background. I think the hurricane's kind of coming towards us, so we might get kind of the edge of the hurricane because I'm in Houston. So if I say students.dtypes, it's not students. I jumped ahead for a second. Let me backtrack. Okay, I did. I scrolled down too far. Okay, yeah, so we talked about a series. Now let's talk about the data frame. So I have a bunch of code here, which I am not going to make you all type out. So I'm going to send it in chat. Also, I think Kendall has a cool comment about NumPy versus pandas, which I appreciate. Thanks, Kendall. So I'm going to send a bunch of code in chat. It's really ugly, but just copy and paste it into a code block. So I'm not going to force you guys to write all that. And this is the code that you should get. This is what it should look like. So what's going on here? We are constructing a data frame, and a data frame takes a dictionary as its, it can take in a dictionary, and you can construct a data frame from a dictionary. If you're not familiar with Python dictionaries, that's totally fine. We're going to walk through it right now. So the basic syntax here is the header name for a column, and then what the column contains. So for example, we can see hair color here, right? So hair color has red, brown, blonde, and so on and so forth. And we can see here that we have hair color, and then a colon, and then PD categorical, and then the list containing all of those hair colors, right? And so to quick explain what's going on here with this PD categorical.
Hey Seth, sorry to interrupt. Did you send the
I
code to the chat?
Yep. I sent it to chat, but I sent it to somebody in private by accident.
Okay, thanks.
My bad. Appreciate that. Thank you. There we go.
There we go. All right,
Cool.
thank you.
Thanks. Awesome. So we've got data frame, we've got the names of the columns, and then we have what the column contains. Here we have two special types of constructors, PD categorical and PD.toDateTime, which are kind of embedded in this. And what they tell pandas to do is interpret this list as a categorical type. So these aren't just like strings. They're actually treated like they're categorical elements. And that'll become more important, and we'll see how that kind of factors into a function called groupBy. But yeah, so we have that. We've got weight, and we have a bunch of dates. So this was the format that were written in that the person wrote for dates. And we can see in the birth date column that those got converted into a slightly different format. And if we were to say students.dtypes, we could see that the name is just some sort of generic object. Hair color is a category, which makes sense because we basically created these colors as we told pandas to interpret them as categorical. We have the weights are 64-bit integers, and the birth dates are these datetime objects. So that's pretty cool. Awesome. So are there any questions about this block right here? That was kind of fast. You probably won't be defining data frames yourself. You'll almost always be like importing them from a CSV or an Excel. But this is an example of how you might construct one by hand. Okay, we'll move on.
Oh, I have a quick question.
Sure.
For one of the Panda functions that you used, what is a PD categorical and what is a toDateTime?
Sure. So PD.categorical, let's actually get rid of that. So I'll show you what this does by getting rid of it. So if I get rid of that and I run this again, and then I check to see what the data types are for these different columns, you can see that the data type for the name column is object, and the data type for hair color, so the objects that are in the hair color column, those are interpreted as just objects. What they used to be when I had PD categorical, and if I run this again, we can see that instead of being considered objects, they're now interpreted as a category type of object. And there's a bunch of cool functions that you can perform on a category type object as opposed to a regular object. So this line here tells us to construct basically a column of category type objects instead of just regular strings. Does that answer your question?
Yes, it does. Thank you.
Cool. Awesome. So we talked about data types. Let's talk about how to access elements once they're inside of a data frame. So if you guys are used to Python or any sort of programming language, usually the way that this works is you have, and I guess it depends a little bit on how you visualize it, but a lot of people are used to like row and then column, right? So you like grab the particular list that you're interested in, and then you grab the element within the list. Depending on how you visualize it, pandas might be a little bit confusing. I know it was to me, because I was always trying to like treat it like a two-dimensional array, and that just doesn't work. So traditionally, how you access items inside of a data frame is you go first to the column. So in this case, if I say student's hair color, that'll give me the column that I'm interested in. So that returns a series for the column that the hair color column. And I'm gonna scroll down here. I have my notes on my second screen. Yeah, so there's two different ways to access a column. We can say students at hair color, right? So put the name of the column inside of square brackets. So that's one way to access a column. You can also say students dot hair color. And that's a really cool way to access a column. This does not work if you have a space in the name of your column. So if hair color was like this, right? So there's a space in the name, and then I try to run this line, right? So I can say that, and then I can also do that. Obviously that doesn't work because I can't have a space in between the name here. So you'd have to just use this method. Do that. I have to run this. Okay, are there any questions about that? No, okay. Could you use .asType to go from object to category data type? If you didn't use, yes, you can. So you can reassign, so if I did not call this categorical, let's hope I remember the exact syntax to do this. I could say students.haircolor is equal to students.haircolor.asType, and then I think, do I just say categorical? Okay, no, you might have to remind me. There's a way to use asType, and we'll actually have an example, I think, down below, but there's a way to interpret a column as a type and reassign it back to students.haircolor. So you basically—
It might be without the string, Seth.
It's not without, it's without the string. So I'd say pd.categorical. Okay, we're not going to get lost down this because we could play around and figure this out. I'm sure just a quick Google search will fix that one, but there is a way to interpret, to basically reassign a new category back into the column that you're interested in. And we'll come back to that one later. Thanks for the question. Okay. Cool. Okay, yeah, so this was the example, right? So we could interpret the weight. So students.weight is equal to students.weight.asType. And here we would say float 64. And in this case, what this does, if I were to print out students.dtypes, we can see that we changed the weight column from a int 64, which was what it was up here. So the weight column held 64-bit integers and now holds 64-bit floating point numbers or decimal numbers. So that's an example of how to convert a column in your data frame into a different type. I think it's probably important to mention that a lot of the functions for pandas don't perform those operations on the data itself. They return that data. So if I were just to say students.weight.asType and I didn't reassign it back, let me rerun this. So we got the students data frame, and we're saying students.weight.asType. Right, nothing changed. And the reason being is that it returns that new column with the different data type. It returns it as a series, and we have to reassign that back. A lot of functions in pandas have the option of saying in place equals true. I don't know if this one has it. This might be wrong. Okay, it doesn't. Okay. But a lot of functions you can say in place equals true, and it'll operate on the data frame itself, so you don't have to reassign back. But in general, that's bad practice. So just use the functions as they were intended to be used. So say students.weight is equal to students.weight.asType. Awesome. All right, so we're moving on. There's a couple other cool aggregation or like quick analysis type functions. So we saw one for the series, right? So we could say s.sum, and it gave us the sum of all the numbers in the series. We can also do students.describe. And what this guy will do is it will describe, and it chooses a column for us. It chooses the one that it can find the most parameters for, but it describes a particular column. In fact, I think I can say include. If I say include all, it'll give us a description for every column in the data frame. So we can see that name has 10 different elements, or excuse me, 10 elements, 9 of which are unique. And the top option is Mara. So Mara must have 2 copies in the data frame. We can also see that because the frequency is 2. Now, obviously, like the mean of the name column, which is a bunch of strings, that doesn't really make that much sense. So those are just kind of null values. So they don't actually, Pandas doesn't calculate those for us because they don't mean anything. But for the weight column, for example, the mean and the standard deviation and all these things might mean something. So this is a cool way to get a quick description of what's going on in your data frame. This is a function that is probably really helpful to call. Like you import the data set and then you just say .describe, and then you get a quick description of everything that's happening. So that can be super useful. Cool. All right. This is where things start getting a little bit more interesting. So I have a picture here for the function that we're about to try. So I'm going to create an actual new text block and delete this one. Okay. So we're going to talk about a function called group by. And what group by does, if given, so you say like the data frame dot group by this. And what group by does is it takes a categorical type and it basically pivots off of that. So we can see in this example, if I called group by on this data frame here, and I said group by color, it would associate all rows of that had that color. So all yellow rows came together, all green rows come together, all blue rows come together. And those kind of stay in their separate objects. And then from there, we can perform an aggregation type of function on each of those. So something like mean or sum or median or mode, like there's all these different types of ways to take objects that have been grouped together and then perform an operation on each of those groups. And then it outputs the result. So this is the second step. Third step, it outputs the result of that aggregation function for each of those categories. And then if you want, you can sort them, which is what the picture here has, but I don't think we're going to do that. So let's look at an example. So if I were to say students.group by hair color, and if I were to just like print out students.group by hair color, it gives me this wacky object. It's like at some reference in memory. This is just craziness, right? So this is the second step, and we can't really do anything with a group by object until we perform an aggregation type of function. So from here, I'm going to say count, and it's going to give me the count for each of those categories for each of those rows. We can see here that the count is the same for each of the columns. But we noticed that it divided things up into blonde, brown, and red. In fact, if we come up to the top, we can see that we had red, brown, blonde, and those are like the three categories. So I'm also noticing while I'm saying this that I don't think I converted this column back to categorical. And I think that the example that I gave of why you would call it a categorical was so that you can use group by. So clearly group by can work on a column that's not defined to be categorical. I think there's a couple other reasons to do categorical. I don't know them off the top of my head though. In general, if you are going to treat a column as a category, it's probably a good idea though. Okay. Students group by hair color count. If I want a particular column here, instead of calling the, well, I bet I could probably call count.hair color, but in this case, I'm going to say hair color count because I'm not interested in redundant numbers. And this returns the count for each of the hair colors. So that's just one example of how to use group by to count the number of hair colors. What was the function? I'm reading ahead. Josh, I got the chat pulled up. What was the function to get to that diagram? Are you talking about the image, Brian? Yes, okay. The image I pulled off of a Medium article, and this is the link to the Medium article. This is a text block, and since we're here, I might as well, I guess it's worth mentioning that text blocks in Jupyter Lab can be written in Markdown. Yeah, it's not a function. So this isn't something that I was expecting you guys to run. It's literally just here so that you guys can see it. We will post all of these, like the full lecture notes for each of these lessons. I think for basically everyone's lesson, as far as I'm aware, will be posted on our website. So if you don't catch everything here, or you want to refer back to the code that I wrote, we'll send the nicer version of everything we're doing here. We'll put it on our website and you can view them there. All right.
Oh, and also Seth, we're at around 45 minutes right now, so you have about 5 minutes left.
All right, I definitely want to get through merge. Okay, that's a good question. Let's save that for Q&A, Lou, since I'm going to try to hurry up here. All right. So we talked about group by. So we know how group by works. We group by a category. We split into like different sections, and then from there we perform an aggregation function, and it moves along that way. One other super important function that I want to get to, I'm going to skip ahead, is the merged function. So I want to say, I'm going to paste some code in chat again. going to send it to everybody this time. And Josh, if you want to take note of Moo, I hope I'm pronouncing that right.
Yep, I already wrote it on the side, and I'll give it to you later.
So everybody go ahead, copy and paste that, that data frame into your code. So we've got these RGB colors. We've got, and if we were to print out this data frame, we can see that we've got, like for brown, we've got red, green, and blue values associated with brown. For blonde, we have different values, right? So what if we wanted to merge the information found in RGB colors with our students' data frame, which has names and hair colors, right? So let's say that we wanted to add the RGB values to those rows where they have like the right hair color. So that would be a merge function. So that requires a merge. So we want to merge these two data frames together. In the interest of time, I'm just going to quick write it out and then give an explanation. If you're good with SQL, you will probably understand what's going on here pretty well. This function is super important because one of the things that we look for at Tama Datathon is, you were given a data set, but did you augment that data set with other information? And this is one of those functions that can let you take two data frames and kind of combine them together. All right, so here we see that we were able to merge two data frames, the students data frame and the RGB data frame on the hair color and color column. And I think this will probably be the last explanation I give, but the way that this works is when we tell it right on color, that and left on hair color, that says for every row in students, looking at the hair color, if there's a match in the hair color value and the color value in RGB, add that row in RGB and that row in the student's data frame together. And it does that on every match and only on every match. So this is what we would call an inner join. There's different types of joins. There's inner, there's left. If you want to specify different types of joins, you would say left or right or outer and inner. Yep. So this is an inner join. Yeah. But you can specify different types of joins as well. But we don't have time to go through that. I think that's about all we'll cover. There's one more thing maybe before we end, and that is how to drop a column. So notice that hair color and color are completely redundant. So maybe I only want one of those. So one way that I can drop a column is I can say merged. Merge.drop color. And then I specify the column axis, which is axis 1. And let me print that out. Oh, that's because I ran it the first time. So I ran it once and it deleted it. And then I ran it the second time and it couldn't find it because it wasn't there. But if I were to print this out after you drop it, it looks like this. And I'll write out that code so that you can see it. So merge.drop color, axis 1 dropped the color column. And I think we're out of time for the first part of this lesson.
So everyone, I'm going to be posting a quick survey into the chat. If you guys could please take a couple minutes just to fill it out. It really helps us get feedback and helps Seth improve his lesson and overall help us improve the overall experience at Tama Datathon. So we're going to take a couple minutes, like 1 to 2 minutes, just everyone please fill it out. And then after you're done, type up your questions in chat and then we'll give it to Seth and see how much information we could squeeze out of him. The name of this course is Data Science Start Here.
So we'll give you guys just a couple more minutes to fill out that survey, and then I think we'll jump into questions. I think we could probably jump into questions now. I think, Josh.
Okay. So there was one question a little bit back. It's from Moo, and it was, what does this portion of the code do? And it was referring to the group by hair color dot hair color part. So like after grouping by hair color, what does calling hair color do? So I guess he was kind of confused by the calling of hair color twice.
Yeah, I think what's happening here is all of those rows, and it's a bit difficult to visualize because what you see here is like it kind of lost a column in that group, but let's assume that it doesn't. So let's assume like visually that all the rows kind of come together that are associated with that particular value. In that case, what you have is basically the data frame split up into like 3 or 4 different sections. And so it still has a hair color column. And so if you say dot hair color, it's all going to be the same hair color, but you're just counting the number of rows there. So that's what it's doing. If I were to call any other column, if I were to say weight, it would give me like the same thing. Does that answer your question? Awesome. Cool. No problem. Okay. Are there
Somebody's asking, are there any links that you can share with us to improve our skills? Basically some just information from videos and courses, any resources that you think would be good for a beginner?
Yeah. So I personally haven't gone through these courses just yet. Yes, and the notebook will be shared. So you'll have this notebook, which, by the way, so I'll just pull it up for a second here so you can kind of see what's going on. These are my notes, which are a bit more in depth, and there's a lot more that we weren't able to cover. Stuff like imputation and things like that. It's just hard to cover all of that in the amount of time that we had. So one of the things that, yeah, Kaggle is a great resource. Notebook will be posted. There's also DataCamp, which is a site that I know Josiah really recommends. Yeah, LinkedIn Learning would be great. So yeah, there's a bunch of places. I think if you're really interested, I will take note of this and I will add a bunch of links into this notebook in particular for learning resources to make sure that you guys know where to go to learn more. And of course, shameless plug, come to TAMU Datathon 2020, which will be a much bigger event. There'll be more workshops, and you can really flex those data science skills. Yeah, I'll be sure to compile a list of links for you guys. I'll make a note of it to myself.
Are there any more questions before we move on to the second part? Oh, here we go. Can you show the last function showing how to drop a column?
Yeah. Right here.
And then also when you're dropping that column, what does the axis 1 do specifically?
Yeah. So you can drop a particular row or you can drop a particular column. The axis tells you which axis to drop or which axis, to drop on. So if you say axis equals 1, this is like axis equals 0, and this is axis equals 1. So the axis equals 1 is the column axis. So you're specifying drop the color column. If I said axis equals 0, think, and then if I said drop 4, it would drop Carson. So we can see that Carson isn't here anymore. Axis 0 lets us drop a particular row. Awesome. Okay, we're just about out of time. Are there any more questions? Oh, yes, I'm sorry. I think you asked that question before. I missed it. To save, if you're working in this colab and it's associated with your Google Drive, this is actually in your Google Drive. So you could go to drive.google.com and you'll see a new folder called, it'll be like yellow and it'll be like collaboratory or something like that. If you click that or you enter that folder, you'll see this notebook. So whichever current Google account that you're signed into, that Google Drive, you should see this notebook saved in. No problem. Thanks for coming, everybody. So again, this isn't over. We're just kind of moving from one section to the next. So we talked about the pandas data frame, and now we're going to talk about some visualization type stuff. So this is going to be kind of a continuation. But if you didn't want to stay for visualization, you don't have to. So these are kind of like, we're treating them like two separate lessons within the same session. And yeah, before we go and do that, I'm going to take like a quick 2-minute break, grab some more water, and I'll be back in just a little bit.
Okay, so for those of you guys who are curious about how TAMU Datathon is going to be working, so last year was the first time we had it, and the first time we could obviously do it in person, but since of the unforeseen circumstances currently, it's going to be all online, all virtual. We're still figuring out all the kinks of exactly how we want to display all the information, all the competitions to you, but right now we're kind of leaning towards like this format right here, so we're trying to use this bootcamp as a learning experience. But the overall experience will stay exactly the same. We'll make sure that you guys are learning as much as you can. You guys are having the ability to actually interact with recruiters, interact with other people. So we want to make sure that, yes, it's online and it's in a safe environment, but we also want to make sure that it's exactly the same. So all the information that you got from those that attended last year, all those experiences that you had, we want to replicate that and maybe even enhance that. Do you have plans to open Datathon for those who are not current students? Could you please elaborate on that? Datathon is open for everybody. All you guys have to do is apply, so make sure you just spread the word.
Yeah, do you have any other questions?
Oh, yeah. And by the way, that's Will. So Will will be monitoring the second half of Seth's lesson. So I'll be going off. But yeah, so
Mhm.
Will can take it from here and he'll be answering a lot of the questions.
Yep, thank you. Yeah, thank you, Josh.
So,
Thanks, Josh. Appreciate it,
all
man.
right. All right. Good luck. Thanks, Seth and Will.
Cool. All right. So let's jump into the second portion, which will be all about a package called Seaborn. I'll pull up my notes here. Okay, again, this isn't a function, this is just a bunch of text, which I meant to do for the previous lesson, but I didn't. Again, it'll be in the notebook that we send later. Okay, so yeah, data visualization, which technically that should say lesson 2. But anyway, we're going to be going over a bunch of cool different plots and how to take, so now we've got this data frame, right, containing all this information, we've got it all clean, we merged some stuff together, now we want to like visualize a bunch of stuff. So we're going to go over the scatter, line, bar, and pie plots. We'll go over heat maps and some different types of distribution plots. So if you wanted to plot the distribution of some variable, these different types of plots can really help you with that. We'll talk about some styling and some theming. And if we have time, we'll go into the exercise, but hopefully we get to that point. Yeah, so we'll be using a package called Seaborn, which is a wrapper around the package matplotlib. So if you are a student at Texas A&M, I think class 22 and 23, you probably are a little bit familiar with matplotlib. I think the intro to engineering classes used matplotlib a little bit. And Seaborn is like one layer of abstraction above that. And Seaborn works really well with pandas. So that's why we'll be learning that. We might touch a little bit of Plotly, which you kind of can see here as kind of higher up on the level of abstraction as well. And at the very highest level is Tableau, which is a web program that is not even code. You can just like drag and drop a bunch of different stuff. And we're not going to be touching on that. But just as kind of a visual, these are the 4 different packages, and they kind of move up in terms of how much code is required to create a visualization. So matplotlib, you get a lot of control. You have to write a lot of code to get it to look the way that you want. Seaborn is a little bit less code, but a little bit less control in general. You have to really like run into a bunch of options to control how those visualizations look. All right, so let's just jump right in and we'll import pandas again, just so we have a nice kind of place to reference. We're also going to import Seaborn. And we're going to import Seaborn as SNS. So SNS is the way that we'll refer to Seaborn. Okay, so I've got a data frame again, the student's data frame. In fact, if you already have the student's data frame, hopefully you copied and pasted it. You can just copy and paste this guy again just so we can reference it. But just in case, I will send the code in chat. So here we go, a bunch of ugly text in chat. If you just want to copy and paste that into a code block, it'd be awesome. I'm going to copy and paste it here. And we're also going to, before we even do that, we're going to see another example of how to merge 2 things together. So I'm actually going to create, and I won't force you guys to type this either. So copy and paste that code, and then copy and paste smaller. send that to you guys in chat as well. So we've got this students data frame. We also have the heights series, and we're going to, and I'm in the interest of time, I'm going to write this out and give a quick explanation for what's happening here. Students is equal to students dot set index join. And what this does is it, instead of having those numbers as indices like we see in the previous data frames that we were working with, we had numbers as the index. I'm going to take a drink of water. In this case, we have, we weren't really interested in having the numbers as the index. Instead, we wanted the names to be kind of the index because that's going to end up being a little bit more convenient for us. So we can actually reset the index to be the name column instead. And we joined it with the heights series. And if you're familiar again with SQL, the word join probably is familiar to you. This is basically a pandas merge, but it's less syntax. And I'm not going to go over exactly how this guy works, but I think it's pretty self-explanatory. It just takes heights and adds it to the students data frame. Okay, and we assigned all of that back into students. Cool. So the first visualization we're going to learn here is the scatter plot. So some code here. Run this. And this creates this pretty basic scatter plot. So just plotted the points, created the axes, and displays it. So pretty self-explanatory. Notice that we referred to the columns by just using the dot operator. Again, two different ways to do that. You could also do it this way. It means the same exact thing. Another way to use this function is I could say scatter plot. If I wanted to specify the x-axis, I say x is weight, y is height, and the data frame that you're getting this data from is the student's data frame. That's a slightly different way to write it. Whichever you prefer, just use that one. Okay. And then really quickly, let's talk about Pearson's coefficient. And I am not an expert on the statistics side of things, but I will just mention one statistic that's really easy to get from pandas is these correlation type of relationships. So how well do two variables correlate to each other? And if you get a, yeah, and Josiah just posted a good explanation of join. If you get like a value, if you get a Pearson's coefficient of 1, that means that the two variables are, they're basically exactly related to each other in a linear relationship. So positive one-to-one type of relationship between two variables. If you get a -1, they have a perfect negative relationship. And then the values in between show, you know, differencing and like they're not a complete linear relationship and stuff like that. So if we want to get the correlations between different variables, I can say students.corr, which is short for correlation. From that block, what I get is a matrix where every single variable is compared basically to itself or to a different variable. So each pair of variables is correlated to each other, and then it gives the Pearson's value for each of those correlations. So we can see that when a variable is correlated with itself, the value is 1, which obviously makes sense because they're the same variable. If we were interested in getting a particular value inside of this matrix, this is a data frame itself, so we can go to the weight column, height row, That'll give us the correlation between weight and height, which is pretty cool. All right, moving on. So there's something called a regression type plot. So if I say SNS.reg plot students.weight students height, run that code block, I get a, and again, this is Seaborn doing a lot of stuff in the background. Is it plotted a scatter plot? It plotted the best fit line through those points. And I'm not super the best person to tell you exactly what this shaded area is. I believe it has something to do with confidence intervals. If you search for Seaborn reg plot, like on Google or something, you can find a lot more information about how this function works and what it's doing. But this is one way to get kind of that best fit line through a bunch of data and also plot the data at the same time. It's a very convenient function to use. We can also plot data slightly different way here. This is kind of cool. So what I did here was I plotted a scatter plot with weight and height, but I also added a color for the different types of data points. So I almost added a third dimension in a way that was represented by color. It's another way I think to think about that. But basically all these points, depending on their hair color, they get colored a certain way. So if you're interested in seeing not just like the data itself plotted, but also which categories that those data points are part of, this might be a function that you use to plot that type of information. And another way to use that type of information is use this function. So this is kind of a combination of that reg plot and the scatter plot with the hue that we saw above. We can see here that we fed it the weight column and the height column. So we said, I think this would be the equivalent of saying x equals weight, y equals height. But now we also added a hue. So this function does not take a hue, I believe. I think I tested that the other day. This guy doesn't take hue, but this one does. And so I can plot the points with their particular groups, so their hair color, and also plot the best fit lines for each of those groups. So if you can imagine having like an enormous data frame with a bunch of information, but each of those, but that information can be divided into categories, this might be a really cool way to plot all those data points and then plot the best fit lines to the different groups. So if you're looking for different types of relationships. So this is a really useful plot. If you want to do like a regular line plot, so just kind of connect all the points and you're not interested in doing a scatter plot, Seaborn offers, funny enough, a line plot. And that's just a regular line plot. So normally those would just be a bunch of points, but the line plot interpolates between those points and just draws lines. I see a question in chat. What is CI equals false? I believe that turns off the confidence interval. How come the colors for the last two data points correlate to different hair colors? Is there any way to make them uniform? Angel, I don't know if I'm perfectly understanding your question. The colors for the last two data points. Do you want to turn on, do you want to clarify that question? You can turn on your mic, by the way, if you're interested.
Oh, yeah. I was trying to get as like in the last plot, the red hair color is green, and then in the other one, the red hair color is orange, represented on the graph.
Right. You were wondering like how would we make blonde like a blonde color and like a brown dot or something like that?
Yes.
Okay. Yeah, actually I don't know how to do that straight off the bat. I bet you there's a way to assign a color to like a feature or something like that. I don't know it off the top of my head though. Usually, and I can probably just safely do this. If you do Seaborn, if you just do a quick Google search, usually you can pull up the documentation for these functions. And there's a whole bunch of options and parameters that you can supply. Like if you didn't want to print the scatter plot along with the best fit lines, you could probably say scatter equals false. But there's probably a way to make that happen. I remember I was going through this and I wondered the same thing. But right now I don't know that off the top of my head. It's a good question. Okay. So line plot, regular line plot, you just plot a bunch of lines between the points. What else do we have? Okay, this is kind of cool. So I'm going to send another data frame in chat. And Will, I'm actually going to stop reading off the questions. If you want to, feel free to jump in and interrupt me with a question that's asked in chat, by the way.
Okay, yeah, I wasn't sure if we were going to save all of that for the end, but yeah, if there's a question, I'll go ahead and I'll let you know.
Cool. And before I move on, I will answer Megan's question, which I saw in chat, but I'll probably just minimize chat for the future because it's getting in my way on my second screen. Would the colors be consistent if you ran it all at once? Oh, without hue? Is that what you mean, Megan?
I mean, kind of related to the previous question. In the different graphs, the colors as they're assigned to each group are not consistent, which can be confusing. So I'm wondering if you ran all of those commands in one block, if that would.
I do believe that I think this would plot, when you're in a single code block and you're running different types of plotting functions, it'll plot, yes, I'll send the code for the data frame in just a second. If I have multiple plots in the same code block, it'll put all of those plots in the same graph. So if I were to run this, I think you're right in that. Oh, actually, okay, it did two. That's interesting. Never mind, I was wrong. Blonde, red, brown, and blonde. Okay, it was not consistent. That's a good question. But yeah, I don't know if there's a way to specify like the colors so that you can force consistency, because I think that's a really good point. That is confusing, the difference between the orange points meaning red in this graph and the orange points meaning brown in this graph. That was a good catch, but I don't know how to fix that off the top of my head. Okay, yes, so the data frame, there we go. Just copy that data frame into here. Okay, so what this data frame contains, in fact, I will start graphing it. Let's take a look at it. It's a bunch of birthdays of people, I suppose, and then house price and their net worth. And we're kind of interested in plotting both of these columns versus the birth date column. And it would be nice to see these on the same graph. So a lot of what happens in Seaborn and Pandas, a lot of the functions are designed around very common, I guess, methods or patterns of work, right? So it's very common to have a data frame where the independent variable or the x-axis is the index, right? So this is the index of this data frame. So plotting all of the columns versus the index is a really common pattern of development. So Seaborn has a really simple way to just plot all the columns versus the index. Say line plot, data equals data frame. And this will give me a very nice line plot of the two variables against the birth date. So this is kind of interesting. You can see how net worth in general trends downward as people are younger, which I suppose makes sense because you haven't had enough time to build up wealth. Cool. All right, so let's talk about styling. So we were able to plot a bunch of really cool graphs, but they're really small and they're constricted to like one side of the page and all this. What if we wanted a graph that was bigger? Maybe we wanted to specify the color of particular points. This actually might answer the question that was asked earlier. There's probably a way to do that. And yeah, so let's go into some styling. So what I'm going to do here is I'm going to import matplotlib. And I need matplotlib. So Seaborn kind of wraps around matplotlib, but I can't really access matplotlib itself unless I import it explicitly. So that's why I'm importing matplotlib. Say plot.figure big size equals. Yeah, I'm just going to write out a bunch of code and then explain what it does. I meant to say true here. What happens when you're typing? Okay, it's a lot of typing. And so what we got here was almost nice. Space there. We get a nice graph with a title, with labeled an x-axis, y-axis. We can see that the tick markers on the x-axis were rotated by 90 degrees. We can also see that there's like a legend, which I think was over here too, but also that the figure is bigger, right? So walking through this line by line, we say plot.figure, which kind of tells plot that we're going to be working with a particular figure in this context. And we can do some, we can actually change the figure size. You can also change the DPI here. So if you want a graph that's higher resolution, say DPI equals 150. And that should make it bigger, but it's a lot higher definition. It's higher definition. We can also set the title. So plot.title, you just pass it in. You can specify the font size and the style. This just creates the line plot. So this kind of specifies the plot itself. Markers equals true. So that adds these points here. I'm fairly certain. Actually, I don't think I ever tested that. Run that again. That should. Yeah. We like those markers. So let's set that to true. Plot.legend, house price, net worth. So that tells us that when showing the different line types, specify, like this specifies these two like names to associate with those lines. Y label is dollars. We rotated the X ticks by 90 degrees. So that's what this line does. And we got rid of the box around the plot. So you can see there's the box here. So this turns off the box. And then we just showed the plot. Are there any questions about everything that happened here? Okay, move on. Also want to mention before I go, since we are talking about styling here, notice that when we said plot.show, it didn't give us that kind of annoying, I guess, object reference or specifier or something like that, description of the object. If you want to get rid of the output on the last line, you can, or you want to get rid of this line in particular, but still keep the graph, you can just add a semicolon to the end of the line. If you run that, it'll print the graph without the text there. So that can be a handy little tool to make your notebooks look nicer.
Hey Seth.
Yes, sir.
What does markers do?
So markers adds these points, these dots, or the crosses in this case, to the different data points. So notice that line plot draws lines between the data points as you travel along the x-axis here. And if I said markers equals false, it wouldn't show the data points. It would just draw the lines. But if I say markers equals true, it adds all those points on the line and it shows those as well. Does that answer your question?
Yeah.
Cool. Awesome. So you know that function group by, which we talked about previously. We're going to use it again. So let's do we're going to get, actually, okay, I'm just going to write out the code and then I'll explain it. What I do here is series group by an object. Students must have gotten messed up here. Apologize for the delay. Let's run that again. Make sure that's okay. These lines ran inside of my notebook. Hair color. Yeah, that's what I meant. Okay. Sorry, I meant to grab the weight column. Cool. So we grouped the students by hair color, and then we grabbed the weight for each of those groups, and then the mean or the average of each of those, of the weights of each of those groups. So we can see that the mean weight for people with blonde hair was 160 pounds, 182 pounds, 143 pounds for red. And so what we did here was we grabbed a series that contained this information, and then we plotted using a bar plot that information. And so what's happening here is we're saying s.index, which gives us the indices here for blonde, brown, and red, blonde, brown, and red. The values, which are these, so those are the values for each of those indices. And then we specified a particular color palette, which is blues D. And then we gave it a title. So that's an example of how to use group by to do some fancy plotting, right? So we pivoted based off of hair color and then plotted those different groups. Okay, and thanks, Kendall, by the way, for answering a bunch of questions in chat. I appreciate that. Cool. All right, so we looked at a bar plot, we've looked at line plots, we've looked at styling. Now let's look at a pie plot. So I'm gonna do the same trick. I'm gonna say students dot group by. And instead of grabbing the weight column when you've associated all these rows together, I'm just gonna grab hair color itself and then grab their count. So the number of rows for each of these groups. I'm gonna say plot.pie. And a bunch of fancy stuff. Can't spell today. Cool. So that gave us a pie chart showing out of the total number of people there are, what's the percentage of number of people for each of these different categories, right? So we used group by to group all of the like the different hair colors into different groups. We got the count of the number of people in each of those groups, and then we plotted those in a pie chart. So we plotted the series where we said that the labels, blonde, red, and brown, we get from the index column, right? So again, you can see that the index for this series actually contains the words blonde, brown, and red. So that's where those words come from. And then this bit here specifies a format string. So I'm not super good with this format in general. I don't think I can use Python F strings here, but this specifies 0.0f means only one or no places after the decimal point. So if I were to say 0.1f, that would show 30.0%, 20.0%. If I said 2 places after the decimal point, you'd have like 2 more spots worth of precision. But in this case, I just wanted to have integer number of percents. So I just said 0.0f. And I believe that the %% is an escape for the percent sign itself. And the percent sign is here, like taking the place of where the number is actually going to come in. So this is like what will be replaced. And yeah, and the 0.0f specifies how many places after the decimal point. Are there any questions about that one? No? Okay. Okay, this is a cool plot. So in this case, we're going to use Plotly. So if you remember up at the top, I said we have Seaborn, which is kind of that middle ground between control and granularity, or control and abstraction. So you can do a lot on a single line, but you still have a lot of control. So we're going to kind of move up one step up the chain, and we're going to write something using the Plotly package, which, by the way, Plotly does a bunch of crazy stuff. If you go search for Plotly dashboard, you can make some like crazy looking data science dashboards with a bunch of like graphs and crazy stuff. You can make it really interactive. So Plotly's really cool. So I'm going to send a data frame again inside chat. So let's jump to chat. That should work. And you're going to just copy and paste that into one of these code blocks. And we're going to import Plotly. Oops, typing in the wrong spot. type that all out correctly. Yes. All right. I got it the first try. Okay, so we've got a data frame for taxi rides, which let's take this code and throw it inside a different code block. So we'll lose our fancy graph for a second. And let's print out taxi rides. Taxi rides is, I guess, just a data frame of like different month and weekdays and then the distance that happened on that particular ride. So I guess each of these rows is a ride. And it just specifies what day and what month. Or I guess what day of the week. And in this graph, what we plot is a heat map of the different months versus the day, where the brightness of the color represents the average distance for that particular combination. So at month 10, I guess to 14, so these are intervals, by the way. So this is month 5 to 9, 0 to 4. If you were to say, okay, months 10 through 14th on like a Wednesday, that's a pretty low number. But on a Monday, it's really high. And on a Friday and a Thursday, it's really high. So maybe people are going out more often during, on Mondays or something. Maybe they're late for work. So heat maps, as long as your two variables are ordered, I think in this case, the weekday is not as ordered as I would like it to be. But in general, if both of your variables are ordered, so your weekdays ordered, your months ordered, they're useful for finding clumps or like little like visual centers that of like activity. So if you're looking at a particular graph and you see heat map and in this case, I was looking at Thursday and Friday as like 2 days that are close to each other, right? So this is like the end of the week and both of them have a high number. That might mean that towards the end of the week, more people are taking long cab rides than otherwise, right? So that might be a relationship that we look for inside a heat map. All right. And you notice that when we use Plotly, there's all this extra stuff that happens here. Like I can zoom out and zoom in, and this is all inside the notebook. So Plotly is pretty cool. You can drag and like look at particular sections of data. This is really fun. So Plotly is pretty cool. Okay. Are there any questions on this work that we just did here? Can the hist function do different things, not just mean? Yeah, I think it can. I don't know the keywords for those different types of functions, but I'm sure you can do like median or something like that. I'm sure there's different types of aggregation type functions for these particular combinations of variables that you can do. Yeah. Good question. Okay, so yeah, let's talk about different types of distribution plots. So I'll actually create a separator here, show off some fancy markdown. Like horizontal line. Okay, cool. So the first distribution type plot that we're going to look at is called the box plot, which I'm going to admit that I'm not an expert on exactly what box plots mean, but super cool. This is how you create one. So using this different palette of colors, which is like, I guess, gentler on the eye, I think there's different types you can probably look up. I think Adil, you just pulled up the different types of aggregation type functions, which I appreciate. I'm sure that you can do a similar search for the different types of palettes that you can use. So here we've got students' hair color, students' weight, and this plot's kind of the distribution of weight for particular types of hair colors. And If you know what box plots means, then you can interpret these correctly. I'm not an expert on box plots, so I'm not even going to really try. I do know that this line here, I'm pretty sure is the median. And these are like outliers or something. I don't know. Anyway, I'm not going to try to explain that one to you guys, but that is how you create a box plot if you're really interested in it. That's probably on my reading list for stuff that I want to understand. Okay, so let's do a different type of distribution plot. So I'm going to write a bunch of code here. Let's actually copy this line. The same thing. It's the same. Just substitute blondes for brown. Okay, and then let's run that guy. So what did this do? So we've got a lot going on here. Let me explain what's happening on these two lines. So when I say browns equals students where students' hair color equals brown, what that becomes is what's referred to as a mask.
Hey Seth, we have about 5 minutes left for the remaining before Q&A.
Okay, cool. I think this is the last plot that I really wanted to hit. There's a couple other really cool plots, but I don't think we'll have time. But this is probably an okay place to stop. Yeah, so so this grabs, okay, so actually this is not a mask. I apologize. There's a different way to create a mask. Actually, this creates a mask, if I were to show that. This is a pretty cool pandas concept. So if I say mask equals student's hair color is equal to brown, this creates a series of true and false values for where the student's hair color is brown. So we can see here that Carson and Kiva and Mara, both Maras, Olivier, all of those people have brown hair. So this kind of creates like a series of true and false values. When you pass that into the data frame interprets that mask or that series of true and false values, and it returns all the rows where there's a true value. So that's how we got just all of the brown, or all the rows with brown hair, and we got all the rows of people with blonde hair. So that's how that works. You create a mask and then you pass that in to these square brackets. So that's what happened there. And then we plotted the brown's weight, which I believe is in, I think this is the blue one, and the blondes is this one, and you can see the distribution of weight as a histogram. If you wanted the regular like normalization, forgetting the name, I'm totally blanking. But if you want this plot, you can say KDE equals true. If you don't want the histogram, you'd say hist to false. And this is a cool way to compare the distribution of two different variables kind of on top of each other, if you wanted to do that. And I guess we'll stop here. Do you have the link, Will?
Yeah, I'm posting the link to your survey in the group chat. And now we'll open up for Q&A.
Actually, instead of Q&A,
okay.
Let's do the, if you guys could, and I really appreciate it, could you do the form first, and then I'll give me a second to like get some more water and stuff like that. And then I'll be back in a couple minutes when you guys are finished with that. Thanks.
Yep. Yeah, just to reiterate, yeah, we really do appreciate y'all filling out the survey. Yeah, we really would like more feedback than less feedback. So yeah, thanks again. Hey Seth, we have a question from Cooper. He's asking, the whiskers on my box plot look a little different. Can you check your version of Seaborn? And yeah, he said, I'm curious, import Seaborn as SNS dot version.
Yeah, I got it. Here you go, Cooper. Yeah, that is kind of interesting. I guess the difference would have to be in the data.
From Megan, she's asking, do you have the same ranges on the y-axis? I guess, yeah, I'm not sure which graph is
I think
Megan
she's
referring to.
yeah, I think she's referring to the box plot.
Okay.
Yeah, I appreciate that, Megan. Yeah, I don't know. I wonder. There might be like a range function on a particular column. Which is there a particular one? Like this is blonde, brown, red. Which one is? Oh, you use box and plot. Oh, okay. Interesting. Okay, now I'm curious. Let's see what that looks like. Oh shoot. Okay, yeah, that definitely looks a lot different. It does look like it's visualizing like the same concept though. Those look a lot more like if you were to graph the distribution. This is not quite like a graph, but it's divided up more, which is kind of interesting. It's kind of cool. So I really appreciate you guys taking the time to come out and attend this lesson. The next lesson in the beginner series is going to be taught by Josiah Code, and he's going to go through machine learning. Josiah is like super good at all this stuff. He's the master. So I really recommend going to that if you guys have the time. And yeah, if there are no more questions, does anybody else have a question before we kind of wrap up here?
From Amira, what does this palette equals paste 2 mean? Or pastel? Yeah.
Yeah, that specifies the color palette to use for the box plot. Yeah, so if I got rid of this line, we would see different colors. So I bet you, taking a wild guess, if there's a pastel 2, there's probably a pastel 1, and that is like a different set of colors, I guess. So it just specifies the color palette to use. And again, there was a little bit more to cover, but I think we got through some of the basics. And yeah, I'll do one more plug for TAMU Datathon. So if you liked what you saw and you're interested in learning more, there is an event happening in October 17th through 18th called TAMU Datathon. And we would really love for you guys all to join us for that event. We're really putting a lot of effort into it. We're going to have like a whole, probably like a live stream so that you guys can have one central hub to get like updates and stuff. We're going to have more workshops. We're going to have workshops hopefully taught by a couple like other industry professionals and stuff like that. So it's going to be a really, really good time. So register on tamadatathon.com and we will see you there.
Thanks for the shout out, Seth. Yeah, please register. We look forward to having y'all.
Thank you so much.
No problem. Thank you for
No
coming.
problem.
All right. We will see you guys hopefully in October.
Take care. Yeah, have a good
Bye.
Good job, Seth.
Thanks, guys. All right. Adios.
Thank you. Have a good one.